Hello students, myself SHASHIKUMAR SK, Department of Physics, IDSG College, Chikmagalur. This is the third session I am going to taking. In the second session, we had discussed about a bridge rectifier. Finally, as we learnt about three rectifiers known as half wave, full wave and bridge rectifiers, AC signals has been converted into pulsating DC signals. But one of the disadvantage of this rectifiers is there will be a pulsating signal, not an entire DC signals are going to be exist. There is a smaller part of AC signals is going to be involved in the output of rectifier. Therefore, to remove those AC component, we use a filter circuit in between the rectified output and the load resistance of the circuit, which means when an output of a rectifier consists of a pulsating signals of AC and DC, to remove that AC signal, a smaller portion of AC signal will be present in the output of a rectified level. To remove those AC signal, we require a filtering circuit. Generally, we used to talk about a filter, which means which removes unwanted things. Here, there is an unwanted thing known as AC signal. To remove those AC signal from output of a rectifier, we use a filter circuit, a device which filters AC component and allows DC component to reach the load resistance are called as a filter circuit, or it is also called as circuits employed for removing of pulsation are called filter circuit or filter network. Therefore, to remove AC signal, we use filters, and these filters are looks like this as a circuit diagram. An output of a rectifier will be connected between the points X and Y. There is a filtering circuit. After a passing of rectified output, the filter circuit removes an AC signals and DC component is going to be reaches at the output of the circuit. Therefore, this filter circuit has a different types, in which we are going to study about three types known as, first one is capacitor filter, second one is choke input filter, and third one is capacitor input filter or pi section filter. So these three are the commonly used filtering circuit in an electronic medium. Okay, let us take three commonly used filters in detail, and first one is capacitor filter. Okay, in the last circuit diagram, we had seen a rectifier at a point XY. There will be a filtering circuit, and then a DC component is going to be exist ಅಂತ ಹೇಳಿದ್ದೆ. So here at a junction of XY, there will be an output of a rectifier which consists of a capacitor in between the rectified output and a load resistance, which means XY in the load resistance signals pass ಆಗೋಷ್ಟ್ರೊಳಗಡೆ we had involved a capacitor of capacitance C, which acts as a filtering circuit, which is a filter circuit. The output of a rectifier consists of pulsating AC signal and DC signal. This capacitor filter is one of the simpler method for smoothing the current. Here a capacitor is connected in parallel with the load resistance. As we are observing, a capacitor has been connected parallel to a load resistance RL. Then this capacitor acts as a filter. As I mentioned that in between the rectified output and a load resistance of a circuit, there will be a filtering circuit. This capacitor filter is one of the most simpler circuit which consists of only one capacitor. So as I told, XY in the end rectified output baratte, that will be passes through a capacitor and then it reaches the load resistance RL. In between this process, an AC signal are going to be removed. That's going to be explained now. This capacitor acts as a filter. Because of charging and discharging a capacitor, there is a AC signal. We know that capacitor will not allows DC signal to pass through it, or that capacitor won't work for the DC signal. It is going to be work for only AC signal. Therefore there will be a process known as charging and discharging of the capacitor. When a pulsating voltage is applied across a capacitor, during the increasing value of the voltage, the capacitor is going to be charged, that is, it stores energy in the form of electrostatic field, which means when an AC signal will pass through the capacitor, then there will be a charging of the capacitor. We know that the AC signal consists of both positive pulse and negative pulse. During positive pulse, the capacitor is going to be charges and it stores the energy, and there will be an electrostatic field. When a voltage will falls, which means when a negative pulse reaches, the capacitor discharges, giving back the stored energy to the circuit. Therefore there will be a balancing between the positive pulse and negative pulse. Hence there will be a balancing. Thus the efficiency of voltage is compensating by the capacitor. This cycle is going to be repeats, but there will be no allowing of the DC signal through the capacitor. Only AC signals are going to be makes the capacitor charging and discharging. There will be only DC signals through the load resistance, which means when if a rectified output consists of a AC signal which is going to be used for the charging and discharging, therefore there will be a compensation of voltage in the circuit. Hence the only DC is going to be flow across the load resistance. Hence there will be a only rectified output will be only DC, not an AC. Hence the AC is going to be removed by the action of capacitor. Only DC is going to be flow through the load resistance RL. Hence the output voltage will not be reduced at all. There will be no reduction of output voltage, since there will be a process of charging and discharging process. Hence there will be a constant output DC voltage. The next, I think you are going to be cleared with this concept, the action of capacitor filter, and the ripple factor of this capacitor filter will be mu is equals to 1 divided by 4 root 3 Fc into RL, where Fc is the cutoff frequency for input filter. The next filter is choke input filter or L filter, or it is also called as inductance filter or L section filter. These are the different names for the choke input filter. It is also known as L section filter or L filter or inductance filter. Here also there is a circuit diagram. I think the circuit has been reduced to a smaller portion. A rectifier is not going to be connected in this circuit, and it is named as 1 and 2, where 1 and 2 are the inputs of L section filter, and 1 and 2, at the point 1 and 2 there will be a connection of the rectifier output. 1 ಮತ್ತೆ 2 ಗೆ rectifier output ನ ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ತೀವಿ, which acts as a input for the filtering circuit. It consists of a choke or inductor known as L is connected in series with the capacitor across a load resistance. Initially 1 ಮತ್ತೆ 2 ಇಂದ output of a rectifier connect ಆಗುತ್ತೆ. Then it consists of an inductance or a choke known as L, which is in series connection with the capacitor C, in which an output voltage is going to be drawn across the load resistance R, which is named as load. As we know that the output of a rectifier is applied at the point 1 and 2, then the AC signals of the rectifier is going to be travel across the choke, which means 1 ಮತ್ತೆ 2 ಗೆ ಏನು rectifier output ಅನ್ನು ಕನೆಕ್ಟ್ ಮಾಡಿರ್ತೀವಿ, it consists of pulsating AC as well as DC. When a signal has been passed, the choke or a inductor will offer a high opposition to the passage of AC. We know that in the lower classes we had been discussed about a action of inductor. That inductor will have a high opposition for the flow of AC signal, but very negligible opposition for the flow of DC signals. Therefore, this results in the loss of AC component across the choke, while a complete DC will be passes through the inductor, which means when an inductor opposes the AC signal and allows only DC signal, there will be a formation of DC signal at the point C. Then the remaining AC signal are going to be observed at the capacitor C at the bypass. At the terminal 3 or at the point 3, the rectifier output contains a DC component. The remaining AC component, which has managed to pass through the choke. Now the low resistance of a filter capacitor bypasses AC component but opposes the DC component. The flow to flow through it, therefore only DC component will reach us the AC. As I told that in the last circuit also, the AC signals are going to be traveled through the capacitor, but DC signal will not pass through the capacitor. Hence, at the point 3, initially what I had told, 1 and 2 are the inputs of the filtering circuit. at the 1 and 2 output of a rectifier is going to be connected. As we know that a rectifier output will having both the what we say pulsating signal, the high opposition for the AC signal across the load inductance L, but passes the DC signal. Then what happens at the terminal 3, the rectifier output contains both DC and AC signal which manage to pass through the choke. In AC signal manage ಆಗಿರುತ್ತೆ ನಿಮ್ಮ ಒಂದು choke ಇಂದ pass ಆಗೋದಕ್ಕೆ, that AC signal will further move across the capacitor, leaving the DC signal at the point 3. Since the choke will make the opposition for the flow of AC signal, but a slighter part of AC signal will pass through the choke along with the DC. Hence, finally, the AC signal at the point P will pass through a capacitor. Remaining DC signal will move across the load resistance RL. And the ripple factor for this circuit is going to be mu is equals to 0.47 divided by 4 omega square LC minus 1, where omega is a angular frequency, C and L are capacitance and inductance of the capacitor, inductance of the inductor. I think you had been understood. Simple ಆಗಿ ಹೇಳೋದಾದರೆ AC ಸಿಗ್ನಲ್ ಮತ್ತು DC ಸಿಗ್ನಲ್ ರೆಕ್ಟಿಫೈಯರ್ ಔಟ್ಪುಟ್ಟಿಂದ ಏನು ಬಂದಿರುತ್ತೆ, ನಿಮ್ಮ ಇಂಡಕ್ಟರ್ ವಿಲ್ ಮೇಕ್ಸ್ ಎನ್ ಹೈ ಅಪೋಸಿಷನ್ ಫಾರ್ ದ ಫ್ಲೋ ಆಫ್ AC ಸಿಗ್ನಲ್ ಬಟ್ ವೆರಿ ಲೋ ಅಪೋಸಿಷನ್ ಫಾರ್ ದ flow of DC signals. Hence there will be a maximum amount of DC signal, but very small amount of AC signal will be comes to a point C. At that point C, AC signal will move towards the capacitor, but DC signal won't pass through the capacitor. Hence there will be DC signal across the load resistance. And the next filter is capacitor input filter or bisection filter. This bisection filter, as the name itself indicates, there is a structural appearance as a pi. Two capacitors are going to be used and one inductor is going to be used along the filtering circuit. As we know that from the rectifier there will be an output which is connected to an input of a filtering circuit. After the filtering process there will be an output of DC voltage. ಇಲ್ಲಿ ನಿಮಗೆ ಎರಡು ಕೆಪಾಸಿಟರ್ ಮತ್ತು ಒಂದು ಇಂಡಕ್ಟರ್ ಕನೆಕ್ಟ್ ಆಗಿರೋ ರೀತಿ ನೋಡಿದ್ರೆ ನಿಮಗೆ ಒಂದು ಪೈ ಸಿಂಬಲ್ ರೀತಿ ಕಾಣುತ್ತೆ, ಹಾಗಾಗಿ ಪೈ ಸೆಕ್ಷನ್ ಫಿಲ್ಟರ್ ಅಂತ ಕೂಡ ಕರೀತಾರೆ. ದೆನ್ capacitor input filter anta kuda karitare, because capacitor will takes the output of a rectifier as an input of a filtering circuit. Therefore capacitor input filter is named. Here what happens, it consists of two capacitor connected parallel to the load resistance and in series with the inductor. ನಿಮಗೆ ಫಸ್ಟ್ ಓನ್ಲಿ capacitor filter ಅಲ್ಲಿ just one capacitor is connected in parallel to the load resistance, but in L section filter inductance and capacitor are connected in series, but that capacitor is parallel to the load resistance. Here what happens, at the load resistance both the capacitor C1 and C2 are parallel, but it is connected in series with the inductance L. Here also at the point 1 and 2 there will be an voltage from rectifier. As we know that it consists of a two capacitors C1 and C2 along with the inductance L. At the first point, the capacitor C1 offers a low resistance to AC component while offer a high resistance to DC component. Therefore, at this C1 allows the large amount of AC, but DC is not passed through the capacitor. Hence, there will be a DC across the inductance L. Here what happens when capacitor is connected at the initial stage, the output of a rectifier will pass through the capacitor C1. Therefore, an huge amount or a large amount of AC signals are going to be taken by the capacitor, leaving behind the leaving behind the DC component, which will move towards the inductor L. Then at the inductor, when the output reaches the inductor, the choke or a inductor offers a high reactance to AC component but almost zero resistance or negligible resistance to DC signal. Therefore, DC signals are allowed, but there will be a blockage of DC signals for a very smaller amount of AC signal will manage to move further. Then at the capacitor C2, again the smaller portion of AC signals are going to be taken by the capacitor C2, leaving behind only the DC signal across the load resistance, which means initially when an output of a rectifier comes to the capacitor C1, it will absorb the larger amount of AC signal, but there will be no absorption of DC signal or allowing of DC signal, or there will be a high resistance towards the DC signal and low resistance to the AC signal across the C1. Then DC signal will reaches the inductance. At the point of inductance, there will be an allowing of only DC signal. Hence, at finally a small portion of AC is going to be reaches the capacitor C2 that absorbs the AC signal. Finally, we are going to obtain only DC signal at the load resistance. I think the action of charging and discharging has been explained in the last circuit. Hence, there will be an output. The output will contains only DC signal, then AC signals has been absorbed completely in the pi section filter, and the efficiency of the pi section filter is more compared to other two filters, and a ripple factor of this is given by mu is equals to 1 divided by 32 root 2 pi cube f cube C1 C2 RL, where F3 is a cutoff frequency. I think you had been understood about a rectifying filter circuit. Finally, our aim is to remove AC signal in the rectifier output signal. By using a filtering circuit, we are going to remove the AC component in the output of a rectifier, giving only a pure DC signals has been taken across a load resistance. In the next class, we are going to discuss about a Zener diode. I think the class has been okay with you. I think you had been understood my class of today's session. If there is any doubt, you can ask me. Thank you.